Right. Hello. Good evening, everyone. I hope you can hear me. First thing. So we'll like we said, we'll start with the energetics questions, right? Can you hear me? Okay. Is it clear, everybody? Ah, yes. All right. Okay. So shall we start then? Right. Okay. Let's start then. So I said starting from question number 11, right? So tell me if you get these answers, we will move on. Otherwise, we will discuss them, right? How about question number 11? Since it is the first question, let us start with that. Calculate the standard enthalpy of combustion of hexane and propane using the following data. So hexanes, combustion is C6H14 combustion. This is a liquid, huh? And then O2, let us say O2, and it gives you carbon dioxide and H2O. Carbon dioxide gas H2O is in the liquid form. Under standard conditions, 6 carbon dioxide, 14, 7, 12, 12 plus 9, 19 divided by 2. Right? That's a reaction, right? Okay. Yeah, so 19 divided by 2. So if you look at this one, 86.06 kilojoules were heated when 1.72 grams of hexane was allowed to undergo combustion. So number of moles of C6H14. What is the number of moles of C6H14? Mass divided by molecular mass. What is the mass? 1.72 grams. What is the molecular mass? 72 plus 14, isn't it? So 86. 86 grams per moles. So if you burn this number of moles, this is the amount of energy that is given out. 86.02 moles. When you burn 0.02 moles, this is the amount of energy given out. How much? 86, 84.06. If you burn 1 mole, what is the amount of energy given out? So delta H combustion is equal to, this is minus how much? 84.06 kilojoules when you burn 0.02 moles. So our value is kilojoules per moles. 84.06 divided by 0.02. 4,203. 4,203. Minus kilojoules per mole. So why do you say minus? Because the energy is given out. All enthalpy of combustions are exothermic. So it's given out. Then let us look at the next one, part B. 1.1 gram of propane was combusted and the temperature of the system was increased by 6.4. Heat capacity of the calorimeter and the contents is this much. How do you get this? Let us look at the total amount of heat absorbed. Uh, what is this? Q is equal to heat capacity is what is given, C theta or C delta T or C delta T. Oh, right, you can use that. C is 8.575 kilojoules per Kelvin. Temperature change is 6.4 Kelvin. So this is the total amount of energy that is released. So that because the combustion is released, this has absorbed energy. 8.575 times 6.4 is equal to 54.88. So 54.88 kilojoules are given out, right? What is the number of moles? Number of moles of propane, C3H8. How much is that? Mass divided by molecular mass. What is the mass? Mass is 1.1 gram. What is the molecular mass? 36 plus 8, 44. Grams per moles. Grams and grams cancels out. That gives you 1.1 divided by 44, 0.025. 0.025 moles. So what is the delta H? Delta H combustion is equal to minus 54.88 kilojoules divided by 0.025. 0.025 moles. 54.88.025 is equal to 2195.2 minus 2195.2 kilojoules per moles. Did you understand that question? Is it clear? Everybody understood that? Check whether you're okay with this. C3 propane, C3H8 actually, not C3H6. C3 propane is C3H8. Propane is carbon, carbon, carbon. This one. Prop means this. It says propane 1, 2, 3, 4, 5, 6, 7, 8. So that is how you get this 44. Right. Is it clear? Right. Everybody got that answer? Right. Okay. Right. Let us look at question number 11. Did you try question number 12? Shall we work on that? Question number 12. Question number 12. Right. Look at this one. Question number 12. Did you get this? Did you get this? Okay. Right. Let us look at this one. 2195 kilo. You don't get anything else. Okay. 554.88 divided by 0.025. 2195.2. Right. Question number 12. Standard enthalpy of formation of carbon tetrachloride, water and carbon dioxide HCl is this much. Calculate the enthalpy change respectively for the reaction. Since the temperature of the system is increased, doesn't that mean energy is absorbed? No, no, no. That liquid absorbs the energy and the combustion releases the energy. Something to absorb energy, the reaction must release the energy. So temperature increases, that is because something is releasing energy. We talked about this last week also. Then is it clear? Everybody understood this. It should give out energy in order for something to absorb. Then make a, like let us say this, when you heat this up, the water temperature of the water increases. That is because that combustion gave out energy. So it's exothermic. Combustion is exothermic. Is it clear? Right. Okay, good. Question number 12. Standard enthalpy of formation, calculate the enthalpy change for the following reaction. So you can use the cyclic method, you can use the equation method. So what is the method that you want me to try? Equation method or the cyclic method? First answer. Somebody gives me the first answer. What method do you want me to try? Equation method, right? Or the cyclic method? Okay, equation method, cyclic method, equation method. Okay, so let us use the equation method, right? You know delta H reaction is equal to the summation of the enthalpies of the formation of the products minus the summation of the enthalpies of the formation of the reactants. So write down that reactants. Okay, so products are carbon dioxide. So delta H formation of carbon dioxide, CO2. plus 4 times the enthalpy of formation of HCl minus reactants delta H formation of carbon tetrachloride CCl4 plus the enthalpy of formation of water. Right, carbon dioxide. Let us see carbon dioxide. What is the value for carbon dioxide? Was at 394 minus 394 plus 4 times HCl. What is the value for HCl? Minus 92 minus enthalpy of carbon tetrachloride minus 107. H2O is minus 242. Let's check whether this is okay, right? So what is the enthalpy change that you get? Let us look at this one. Minus 394 minus 42 times, no, not 42, 92. 92 times 4 plus 107 plus 242. What is the answer that you get? 242 තව එකක් තියෙනවානේ water දෙකක් තියෙනවානේ. So 2 times water. Right? So that is plus 242 is 171 minus 171. Is it clear? Right. Everybody understood that? Everybody clear? Right. Okay. That was question number 12. Come to question number 13. Do you want me to try that out? Did you get the answers? Right? Okay. But let us do that. Yeah. Right. Okay. You got the answers. But anyway, we'll try that out. Standard enthalpy change of C2H5CHO is this one. Calculate the enthalpy change of the calculate the enthalpy change of the reaction given below. Standard enthalpy changes of C2H5 and CH3 277 and minus 188. It's like enthalpy of formation, right? So if you look at this one, delta H reaction is the summation of the enthalpy of formation of the products minus summation of the enthalpy of the formation of the reactants. Enthalpy means enthalpy of formation. Enthalpy of formation of products is C2H5OH. What is C2H5OH? Minus 277. The other one is minus 184 kilojoules per. What is the value? Minus 277 minus 184 is equal to minus 93. Is that answer? Okay, right. Minus 93 kilojoules per mole. That's easy, na? That's easy one. Use the given data in the given table, calculate the standard enthalpy of the following reaction. එකත් පුළුවන් නේද? So same thing, ammonia gas. HBr is gas. And ammonium bromide, NH4Br. So since we use the equation method, we will try the cyclic method here. So what is the cyclic method? Here you write elements. Nitrogen gas. What else? Hydrogen gas. And then you have bromine liquid. Hydrogen is 3 plus 1, 4, 2. Nitrogen is half. Right? These are the elements that you need. Now, enthalpy of formation of ammonia. What is the enthalpy of formation of ammonia? Minus 46 kilojoules per mole. Right? Enthalpy of formation of HBr is minus 36 minus 36 kilojoules per moles. What is the ammonium bromide? Minus 271. Minus 271 kilojoules per moles. Now there is delta H reaction. So using the Hess's law, using Hess, what do you get? Minus 46 minus 36 plus delta HR is equal to minus 271 kilojoules per. What is delta HR? That is minus 271 plus 46 plus 36. 189 minus 189 kilojoules per moles. Did you understand that? Everybody got, I hope you all got the answers there. That was question number 13. 14, did you get the answer? Did you try that? And did you get the answer? If you're okay, I'll omit that and part 1 and part 2. Anybody you want to try this? Can't you calculate that using the equation? Puluang. Karana puluang iting. We use these other ones, you should never get into the habit of one thing. Try because you don't know what the exam will tell you. You're getting ready for that. So don't use the same method. You try using different methods as well. Right? Come with the question number 14, 1 and 2. Question number 14, 1 and 2. How about that? 14th, right? 14th, Mama I'll do the second one, right? And now some people ask me, 14th one, because they are all very similar, I think. Put a try karanda. Right? Okay. Standard enthalpy changes of the combustion of this carbon and hydrogen are respectively. Calculate the standard enthalpy of formation of this, right? So in order to do this, let us look at the combustion. Carbon, triple bond carbon, hydrogen. This is the gaseous phase. Reacts with oxygen. Gives you carbon dioxide and water. Right? 2 carbons, 2 carbons. Hydrogen is 2, hydrogen is 2. 2 times 2, 4 plus 1 is 5. This is 5 divided by 2. Right? Let's check whether it is balanced. Right? Double check. 2 carbons, 2 carbons. Hydrogen is also 2. 1. 2 times 2, 4 plus 1 is 5. 5 divided by 2 is the standard enthalpy change for the combustion is 1300. So this is minus 1300 kilojoules per moles. Then it says calculate the standard enthalpy of formation. Okay, so in order to form C2H2, you have to use carbon, you have to use, of course, hydrogen, and also you have to use oxygen. Then 2 carbons, hydrogen is 2, oxygen is 5 divided by 2. This is called enthalpy of formation, right? Standard enthalpy of formation, delta H standard formation. This is carbon dioxide. It tells you it's a combustion of carbon. Combustion of carbon is the formation of carbon dioxide. Minus 394 minus 394 multiplied by 2 kilojoules per moles. Right? And then hydrogen, the combustion is how much? 286. So minus 286 kilojoules per moles. Right? Kilojoules per mole. Right? I don't know why do you get a line like that. Kilojoules per moles. Right. So now let us calculate the using the Hess. Using Hess cycle. So this is what I do. I will start from here. I'll go to this side. And then from this side, I'm going to continue it over there. That's the idea, right? So we say first step is delta H formation minus 1300 is equal to minus 394 times 2 plus minus 286 kilojoules per moles. So what is the enthalpy of formation? What is that value? Minus 394 times 2 minus 286 plus 1300. Plus 226. Plus 226. Are you happy with that, children? What do you say? Is it clear? Everybody got those answers? Ah, right. This is okay. Done. Right. Everybody okay with that? So, right. Question number 14, can I leave or do you want me to do this? If you still have a problem, I can still work it out. Right? Haridha? Anyone? Please do, Kilatino. Right. Okay. So let us do that also. First one. Right. CH2 double bond CH2 plus HCl. This is a gas. Plus HCl gas. Giving you C2H5Cl. Right. The standard enthalpy change for the formation of this one, respectively calculate the enthalpy change of the following. Right? So you can say delta HF summation is equal to summation of the enthalpy of formation, the reaction. Summation of the enthalpy of formation of the products minus summation of the enthalpy of formation of reactants. Products are C2H5Cl is minus 105 minus C2H2. C2H2 is plus 52.3. HCl minus 92.3 kilojoules per moles. Minus 105 minus 52.3 plus 92.3 is equal to minus 65 kileno. Right. Okay. 15, 16, 17, tell me one of those questions to discuss. 15, 16, 17. Right, okay. 17th question. Right, let us do the 17th question. Right, 17. Right, read the question. Standard enthalpy of combustion for hydrogen C6H10, C6H12 are these. Calculate the standard enthalpy of hydrogenation. Hydrogenation means reacting with hydrogen. So this is what you have. It says C6H10, C6H10 liquid. Add hydrogen gas to it. When you add hydrogen gas to it, you get C6H12 liquid, right? The standard enthalpy of combustion of this, wait, question number, standard enthalpy hydrogen combustion, this calculate this. So this is the reaction. This is the enthalpy chain that you want to calculate. This is the enthalpy chain that will. But they say, okay, the combustion is given there. So let us burn it with oxygen. So let us burn it with oxygen. If you burn it with oxygen, this side also you have to burn it with oxygen. What would you get? If you burn it with oxygen, you burn it with oxygen, you get carbon dioxide. What else? you get water. How many carbons? You need 6 carbon dioxide. Hydrogen, 10 here, 2 here, 12 here, that means 6. Reaction. How many oxygens do you need? 6 times 2, 12. 12 plus 6 is 18. 18 means you need 9 oxygen to this side. If you put 9 oxygen to the left hand side, you have to put 9 oxygen to the right hand side as well. So this is combustion. Right. Standard enthalpy of combustion of hydrogen is this much. Hydrogen we burn. What is the amount of hydrogen? Minus 241. Because you are burning only 1 mole of hydrogen. C6H10 is minus 3800. 3800 kilojoules per mole. You are burning C6H10 also. 3600. And the other one is minus 3920 kilojoules. Right. So now what is the method? You go from here to here and this one. Right. That's my application of the Hess's rule. Right? Delta HR minus 3920 is equal to minus 3800 minus 241 kilojoules per moles. So what is the delta HR value? Delta HR value is equal to, what is that? Minus 3800 minus 241 plus 3920. 121 minus kilo. Minus 121 kilojoules per moles. Did you understand that? Did you understand that? I use enthalpy level diagram for the previous one. Come on now, because we haven't you haven't been told what is to use, right? What is it? Yeah. Is it clear? Well, again, in question number 14, part 1, formation enthalpy is given. Well, again, formation part 1. Question number 14, part 1. Formation enthalpy of C2H2 is given. Again, that is not part 1. C2H2, C2H4 it should be. Yeah, correct. I also didn't see. C2H4 it should be. If you use C2H2, you can't do it. It's a typing mistake. It should be C2H4, right? Okay. You got it? What is that? Right. Question number 16 also. Right? Question number 16 as well. Calculate the standard enthalpy of formation of C2H5 compound, and this is the standard enthalpy of actually not formation. Correct. I think it is combustion because the formation values are given. So this should be carbon solid formation. Now this is combustion. This data is combustion. This is formation. Then correct. This compound. The compound is given. Compound, this should be delta H combustion. Right? Because these are very large values. So it says carbon is equal to minus 394. Hydrogen is equal to minus 286. C2H5OH liquid is equal to minus 1400. And then what they ask is calculate the standard enthalpy of formation of this. since there's a mistake, correct combustion. So C2H5OH. Let us burn it. Oxygen gives you CO2H2O. CO2 gas. And this is H2O also. H2O liquid. Right. Two carbons, two carbons. 5 plus 1 is 6. 6 means 3 hydrogens. 2 times 2, 4 plus 3 is 7. 7 minus 1 is 6. That is 3 oxygens. So this is your reaction. This is the reaction. And then here carbon solid graphite is there. Plus you have hydrogen. And this is oxygen. Okay. How many carbons? You need 2 carbons. How many hydrogens? You need 3 hydrogens. Oxygen, 3 times 2, 6 plus 1 is 7. 7 divided by 2. So ethanol is produced. Carbon dioxide is produced. H2O is also separately produced. Right. Combustion of ethanol is what? Minus 1400 kilojoules per moles. That is okay, na? Like, using this data. Right. Carbon combustion is 394. This is minus 394 multiplied by 2. Why? Because there are 2 carbon atoms that is burned. H2, hydrogen, minus 286 multiplied by 3 kilojoules per moles. Make the delta H reaction. Right. So we say delta H reaction minus 1400 is equal to minus 394 times 2 minus 286 times 3 kilojoules per moles. So what is the delta HR value? What is the delta HR value? What is the value? You get minus 394 times 2 minus 286 times 3 plus 1400 kilo. 246 kilo or minus 246 kilojoules per moles. If you couldn't do it, that is because maybe a mistake, right? Maybe might have not identified. That's okay, na? Now it's okay, na? Right? Is it clear? Okay. So 15, 16, 17. Come with the 18, 19, 20. Which question do you want me to discuss that? There. Right? 18, 19, 20. Right. Okay. Let us look at 20. Question number 20. Question number 20. Right. Where is that? The standard enthalpy of combustion of sulfur rhombic minus 287 for 1 mole of atoms of sulfur. Standard enthalpy of formation of hydrogen sulfide and H2O is this much. Calculate the standard enthalpy change of the following reaction. Right. So what is this? So it says SO2 gas. What else? 2 hydrogen sulfide gas. Giving you 3 sulfur solid rhombic plus H2O liquid. Okay. So the standard enthalpy of combustion is this one. Formation of hydrogen sulfide is this much, respectively, and then do the calculation, right? Okay. So let us say you need sulfur here, solid rhombic. And then you need hydrogen here. And then you need oxygen also. Right. Sulfur, you need 3 sulfur. Hydrogen, 2 hydrogens. Oxygen is this much. Standard enthalpy of combustion of sulfur is minus 287. So you are burning only 1 mole of sulfur, right? So that you are getting 1 sulfur dioxide. This is minus 287 kilojoules per moles. Out of 3 sulfur, you take only 1 sulfur and burn it with oxygen. Correct? So you get sulfur dioxide, right? Standard enthalpy of formation of hydrogen sulfide. Hydrogen sulfide you can form. What is the enthalpy change? Minus 20.2. 20.2 for 1 mole, but there are 2 moles here. 20.2 kilojoules per moles. Right? Now, on this side, you don't have to form sulfur, and sulfur is already formed. Its element H2O formation is minus 286. This is minus 286 kilojoules per moles. That value is delta H reaction. Minus 287 minus 20.2 multiplied by 2 plus delta HR is equal to minus 286. What is the unit? Kilojoules per moles. So delta HR, shall we calculate that? Minus 286. Plus 287 plus 20.2 multiplied by 2. What is the answer? 41 kilogaanak. What is the answer given? Question number 20. This should be plus 41.4. Anybody who can confirm this answer? Isn't it 2H2? 2H2. Yes, yes. Right, then this is 286. Balance upset 2 times 2, 4. 2 times 2, 4. 286 times 2. But let us do the calculation again. I forgot, I made a mistake. Made a mistake. 200, that is minus 286 times 2 plus 287 plus 20.2 multiplied by 2. 244 කියලා ඒත් වැරදි. 244. 244.6 kilojoules per moles. Did you all get that? Anybody who has got that answer? Yeah, okay. There's somebody asked me, why can't you get S8? S8 ඉතින් ගන්න ඕනේ නැහැ because you know you're talking about atoms here. 1 mole of atoms S8, if you write S8, you need to say 3 divided by 8. එච්චරයි. I think you don't have to get S8 because it is sulfur that is there. Right? You don't have to say S8. Right? Carbon also, that is also in the polymeric form. Right? Okay, you got it. Right. That answer is wrong. By 244.6. I'll correct it. 244.6 kilojoules per moles. Right. That is question number 20. But how about 19 and 18? Did you get those answers? Yeah. That is why it is not printed there properly. Okay. Thank you. Thank you. That is where the mistake is. Yeah. Is it clear? Yeah. Okay. So all of you have got it. Come with the question number 19, 18, 18, 19. Can I proceed without them? 18, 19. Can you discuss question number 17? Hari, question number 17 also. Right? Question number 17. Standard enthalpy of combustion of hydrogen C6A. I didn't do it. Question number 17, I didn't discuss. I think 17 discuss. right? Okay, we discussed that. Now, today itself. Hari. 18, 19, 20. Are they okay, or anybody who couldn't do it? Hari, question number 20 will 21 will under calling. We will look at question number 17, 18, 7. Yeah, we did 17. 18, 19, 20. Anybody having problems with that? Right? So right? Okay, 19. Question number 19, Balamuhin. Question number 19. Question number 19 says, calculate the standard enthalpy of formation of one propanol using the data given below. The combustion is given there, right? C3H7OH. This is a liquid, right? And you burn it with oxygen. When you burn it with oxygen, you get carbon dioxide and water. Balance karan. 3 carbons, 3 carbons. 7 plus 1 is 8, 4 hydrogens. 2 times 2, 2 times 3, 6 plus 4, 10. 9 divided by 2. Right? Combustion is minus 2010 kilojoules per moles. Right. Okay, so what do they ask? They ask you to calculate the formation. Right. Formation means carbon, solid graphite, hydrogen, and then oxygen. Carbon is 3 carbons. Hydrogen is 7 plus 1 is 8. That means 4, 9, 10, 10, 5 oxygens you need. So this is the enthalpy of formation of this. That's what they ask you to calculate. Delta H formation. What is this? 3 times carbon dioxide. That is 394 times 3 kilojoules per moles. You must say H2O. Hydrogen. Hydrogen 4. 286 times 4 kilojoules per moles. Delta H formation minus 2010 is equal to minus 394 times 3 minus 286 times 4 kilojoules per moles. So what is the delta HF value? Minus 394 times 3 minus 286 times 4 plus 2010. 316 okay, minus 316. What is the answer given? No problem. Answer is there. You okay with that? Everybody? Right, okay, fine. Right, okay. So 17 we discussed, 18 I didn't discuss, you can try that out. And then 19 I discussed. I think 18, it's like very similar. Oxygen ko balance natte, which one? Are we talking about oxygen is not balanced? Can which question? Can balanda taggal can? Oxygen is not balanced. Which one are we talking about? Which question? Question number 19. Yeah. It was a previous question. Previous question, which one? The question number 20. Yeah, right. Then you balance ni? Right, okay. Right. It was say, what is the next one? Question number 20. But again, 21, 22, 23. Right? Anything that you tried and then you couldn't do it? Can 21, 22, 23. 21, 22, 23. Out of that, tell me what is the question that you want me to discuss. 21. 21, question number 21. Ammonium nitrate is frequently used as a fertilizer and can also be used as an explosive. Formation values are these ones, respectively. Calculate the heat released by the dissociation of 1 mole of ammonium nitrate according to the following reaction. If you look at this one, 2 ammonium nitrate solid, it gives you 2 nitrogen plus 4 water and then 1 oxygen gas. This is oxygen, this is liquid. Right. Formation enthalpy of ammonium nitrate is, again, you have to have nitrogen. You have to have hydrogen. Also, you have to have oxygen. Nitrogen is 2, hydrogen is 4. That means 2. Oxygen is 3 divided by 2. Right? So, formation enthalpy is 365. So, this is 365 minus 365 multiplied by 2 kilojoules per moles. Nitrogen, you don't have to form. Hydrogen, if you want to form into water, you need 286. So 286 multiplied by 4 kilojoules per moles. Oxygen, you don't have to form because it's an element. So let us calculate the delta H reaction. Here, 365 multiplied by 2 plus delta H reaction is equal to minus 286 multiplied by 4 kilojoules per moles. So delta H reaction, how much is that? Minus 286 multiplied by 4 plus 365 multiplied by 2. So 414 kilojoules per moles. You can see it is for how many moles? It is for 2 moles. Here you are looking at 2 moles. So for 1 mole, 204, this one value divided by 2, minus 207 kilojoules per moles. Is it clear? Right? Is it clear? Did you understand that? Everybody understood this? Right? Now you can't use the always you can't use. Now for this one, you should be able to use it is enthalpy of formations. So enthalpy of formation, you can use the equation method also and do the calculation. You can use that enthalpy measure method, the enthalpy what is this equation method, and do the calculation also, as long as formation enthalpy is given. Otherwise, you can't do this. Right? Everybody okay with that? Right. That was question number 21. What is the next one out of that? Let us look at question number 22 also. Discuss right? Okay. Question number 22. Let us look at this. Question number 22. Standard enthalpy or dissolution of sodium sulfate is this much. Calculate the delta H R of this reaction. So sodium sulfate, Na2SO4 solid plus 10H2O liquid gives you sodium sulfate Na2SO4 decahydrate 10H2O solid. Right. Now we need to look at the dissolution. So dissolution means add water. So here you are adding water to this side, right? And here also you are adding water to this side. That water is a large quantity of water, right? And that will give you sodium ions aqueous and then sulfate ions. That's all. The compound will dissolve and break into ions, and that gives you the solution. So sodium sulfate when you dissolve this, there's some amount. This one dissolves there, there's some amount. What are the values? Standard enthalpy of dissolution of sodium sulfate is minus 2.4. So to make a minus 2.4 kilojoules per moles. Sodium sulfate decahydrate is equal to plus 70.2 kilojoules per moles. And this is delta HR. So what would you get? Delta HR plus 70.2 is equal to minus 2.4 kilojoules per moles. What is delta HR? Delta HR is equal minus 2.4 plus, no, minus 70.2. It's right. 72.6 minus 72.6. That's okay. You put it try that right? Without like hanging there. Right? Okay. Is it clear? Right. Okay. So question number 22 is that. The 22, 23, how about 23? 23 is also very similar. Right? 23 is also very similar. All right. Everybody okay with that? Question number 21 I didn't understand question number 21 which part you didn't understand that? Please count and show the nitrogen atom. Why don't you count it? How do you count it? Methana tina nitrogen atom, methana ikai. Methana dekai. 2 times 2, 4 nitrogen atoms. Here also 2 times 2, 4. What is the question? There should be no problem with them. Then, what is the issue there? Huh? But we put nitrogen in the atoms down can? What? It doesn't matter. Balance it doesn't matter. It doesn't affect. It doesn't affect the calculation. That doesn't affect the calculation. Right? Because we are looking at 365 times 2, this value. Okay? The calculation is not affected. You balance it according to that. But that doesn't affect the calculation. Arne? Yeah. Okay. Yeah. So now, yeah. So oxygen, everything should be balanced according to that. Yeah. So maybe that is what you're asking. 2 times 2, 4 is 2, 4, right? Hydrogen, 2 times 4, 8. So this is also, it should be multiplied by 4, the 4 times 2. 2 times 3, 6. 6 means, yeah. So that is that. But that doesn't affect the calculation. That doesn't affect the calculation. Because we work according to the reactants present, not the elements that are there. Are you clear? You have understood that. In question number 22, why did you add extra water? Because it is dissolution. Dissolution means you have to add water and dissolve. So you need to add some excess large quantity of water, not 10, many millions of water in order to create 1 liter of the sample. Dissolution means you're making 1 liter of the sample, 1 liter, 1 moles per cubic decimeter sample. Did you understand that? Right. Okay. Right. Okay. Right. Fine. Then that was question number 22. Right. Now tell me, out of question number 24, 25, 26. 24, 25, 26. Tell me what is the question that you like to discuss first? බලන්න ටක් ගාලා කියන්න බලන්න if you have tried it. Again, don't we need the formation enthalpy of nitrogen in the question? With the nitrogen, you don't need the formation. Formation of nitrogen, nitrogen is an element. Formation enthalpy of nitrogen is 0. So you don't need it. Right? Question number, which one? Right. Question number 25. Right. Let us work on question number 25. Question number 25. It says the combustion enthalpies are given to this. Calculate the enthalpy change of the following reaction. Right. So C3H8, C3H8 gas plus you have hydrogen gas giving you C2H6 gas, and this is CH4 gas. Right, okay, so let me get this to a kind of a proper centered manner. Right, okay. So now once you have that, let us burn it. Now, because everything is combustion, all these things are combustion, I think. Except one, the last one is, it says formation. Maybe that is also combustion. I am not sure. We'll see. Balum, try balum. C3H8 hydrogen. Okay, right. Hydrogen combustion. Methane is also combustion is given. C2H6 is also combustion. Okay, right. C3H8 formation is given. So let us see carbon solid graphite. And then you have hydrogen. Yes. So if you want C3, I'm assuming that there is no mistake. Killer formation, we will take it and do the calculation and see. Right? 3 carbons, hydrogen, 8 plus 2, 10. 6 plus 4, so that means 5. Right? So C3H8 minus 104. So this is, the formation is minus 104 kilojoules per mole. Right? You got a hydrogen. Now what you do is, you have to burn this. Right? Combustion. So let us burn it. Let us add oxygen to this. When you add oxygen, what will happen is it gives you, what does it give you? It gives you carbon dioxide and water. No, H2O. How many carbon dioxide? Shape how many carbon dioxide would you get? Here there is 2 carbons, here there is 1 carbon, altogether 3 carbon dioxide. How many hydrogens, water molecules would you get? 6, 4, 10, that means 5 water molecules. Right, when you burn it. In order to burn this, how many oxygens do you need? 3 times 2, 6. 6 plus 5 is 11. So 11 divided by 2. Take it to this side a little bit. And then I will erase this. 11 divided by 2 oxygens. 11 over 2 oxygen. And right. Now let us look at the enthalpy for that. Now you are going to burn C2H6. C2H6, when you burn it, you know 1560 minus 1560. CH4, when you burn it, minus 890. Minus given 344. So if you are burning carbon to carbon dioxide, minus 344 multiplied by 3, because 3 carbons you are burning to carbon dioxide. Hydrogen 286. Hydrogen 286, you are burning 5 hydrogens. 286 times 5 kilojoules per mole. Here So here also kilojoules per moles. Now, let us look at the enthalpy cycle. So starting from here, you go to this point, right? Or maybe starting from here, you go to here, you go to this point. And on the other side is this direction. These are the two things, right? So let us look at that. Minus 104 plus delta H reaction minus 1560 minus 890 is equal to minus 344 times 3 minus 286 times 5. What is the unit? Kilojoules per moles. So let us look at delta HR. What is the value that you get? Minus 344 times 3. That is the minus 286 times 5. Right. Plus 1560 plus 890 plus 104. So plus 92 kilo. But I'll leave you this to study a little bit. This is what I took. Starting from here, and then from here, and then I went to this side. That is the delta H. I'm going to check whether you got this one. Question number 23, we'll look at it. First, we understand this, will you? Right? Try that. We'll look at the other ones. Make a harida. Is this okay? Whether you understood that? Right. Right. Okay. Good. 11 divided by 2 oxygens needed. Right. Okay. Got it. Can you explain the whole question again? Well, බලන්න මේ recording එක ආපහු බලන්න. I think that is the best thing to do, නේද? අපරාධෙන් නැත්තම් වෙලා. Right? So look at that. Because slow කරලා බලන්න. Right? Just going through it. What you have is this one is a formation. So what I did was I formed this compound C3H8 එක form කරා. Right? And then based on that, I wrote that other reaction, C3H8, hydrogen, C2H6, and CH4. But then other ones are combustion, so I add oxygen, and I burned everything, and then try to connect it somehow or other. Right? Please look at this, it's available in the website. You can double check, right? Okay. And what is this? Isn't the hydrogen on C3H side C3? What is that? Hydrogen on C3H8 side undergo combustion. Okay, combustion hydrogen. It has not turned into anything. The oxygen has not reacted. Oxygen has not reacted. This is oxygen. This is also oxygen. That reaction, that particular reaction, or nothing has happened to oxygen. It has reacted with C3H8. That's all. Is it okay? Is that clear? Right. Shall we go to another question? What is the next one? I will send you this document. Right. Question number 25. What is the question number 25 was that? What is the other one that you want to look at? Right? What is the other one that we want to look at? Question number? No, out of these three questions, 24, 25, 26. What is the question that you want to look at? 27? 27 also. 27. Right, okay. 27, combustion of C2H2, hydrogen C2H6 are this one. Calculate the enthalpy change of the following reaction. It will be triple bond CH. It's gas. And then you have two hydrogens. Gas. Giving you C2H6. Gas. Add oxygen to this side. Why do I add oxygen? Because it says combustion, burn. You have to burn it. If you add oxygen to this side, you have to add oxygen to this side also. And then when you burn it, you get carbon dioxide and water. Carbon, two carbons. Hydrogen, 2 times 2, 4, 5, 6. That means you need 3 water molecules. How many oxygens do you need? 2 times 2, 4 plus 3 is 7. 7 divided by 2. So this is also 7 divided by 2. Right? Right. Okay. So what do they say? Combustion of C2H2 is 1301 minus 1301 kilojoules per moles. Right? Hydrogen is minus 286. What do you have burned? 2 moles of hydrogen. Minus 286 times 2 kilojoules per moles. Right. And then C2H6, 1560. 1560 kilojoules per moles. And this is delta H reaction. Now, when you're writing these for the exam, you don't have to write separate equations. All the balance equations are there. But make sure to write the physical states, make sure to balance them. Without all the marks are given. Right? So, you can say using Hess. Delta HR minus 1560 is equal to minus 1301 minus 286 times 2. Double check. What is the delta HR value? Delta HR value is minus 1301 minus 286 times 2 plus 1560 minus 313 minus 313. What is the answer? Yeah, minus 330. Question number 27. 28, 29, 30. 28, 29, 30. Right? Out of these three, 28, 29, and 30. Out of these three, which one to discuss? 28, 29, 30. What is the reaction? Question number 30. 30. Enthalpy of formation of carbon dioxide and water, this one. Ethane is this much. Hydrogenation enthalpy of ethene with the gas is hydrogen. How much is this? Right. So ethene means CH2 double bond CH2. Ethene is that. Hydrogen gas. When you do organic chemistry, you will understand it better, right? So ethane is CH3, CH3. Eth means you have two carbon atoms. No, my reaction. Right? Enthalpy of formation of carbon dioxide and water, respectively, combustion of ethane is this much. Right? So ethane. Hydrogenation enthalpy of ethene with the gaseous hydrogen and is this much. Calculate the enthalpy of formation. Right? So anyway, you have to burn this. Right? Combustion of ethane is this. Right? Okay. So let us burn it. Oxygen දාමු දෙපැත්තට නේ. Oxygen plus oxygen. Right. Let me get this properly into one place. Put them again. So we'll erase this and get the proper amount of oxygen. Otherwise, there's no space. Right. So when you burn it, what would you get? You get carbon dioxide and water. Two carbons. 2, 3, 3, 3, 6. That means 3 water. 2 times 2, 4 plus 3 is 7. This is 7 divided by 2 oxygen. And here also you need the 7 divided by 2 oxygen. Enthalpy of formation of carbon dioxide and water are this much, respectively. Combustion of ethane is 1560. Make tamai 1560. Ethane is this. This is 1560 kilojoules per moles. This is called ethane. Right. ඊට පස්සේ තියෙනවා hydrogenation enthalpy of ethene with gaseous hydrogen is minus 138. එතකොට මේක තමයි this is hydrogenation. This is what is called hydrogenation. නිකන් just to hydrogenation. Minus 138 kilojoules per mole. So CH2 double bond CH2 reacting with hydrogen to give you CH3H3, CH3CH3, that is 138, right? And then what they ask is calculate the formation enthalpy of C2H4, right? So in order to get formation, you need solid hydrogen and also oxygen. Oxygen 7 divided by 2. Hydrogen how many? You need 2 of them. Carbon how many? You have 2 carbons. You need 2 carbons. This is what is called the formation. Formation. This is the enthalpy of formation. Standard enthalpy of formation of C2H2. Right? You don't have to form hydrogen. You don't have to form oxygen also. But they have given these values. This carbon dioxide value and H2O values, I think they have given as the first thing. Formation of carbon dioxide is 394 minus 394 times 2 kilojoules per mole. Water minus 242 times 3 kilojoules per mole. And then, like you start from here, these are the arrows, you come up to that point. And on this side, you go this direction. Right? So using that data, delta H formation, enthalpy of formation, minus 138 minus 1560 is equal to minus 394 times 2 minus 242 times 3 kilojoules per mole. What is the enthalpy of formation? Then minus 394 times 2 minus 242 times 3 plus 138 plus 1560. And 184 kilena plus. That was question number 30. Question number 30 කියලා කිව්වා. Right? Right. Some of you would say 29 also. එකත් අපි බලමු. 29 also we'll look at it. Right? Not 12. හරිද? This is okay na? I'll leave that like that, just like that. Right? So you can have a look at that. Question number 29 also. When workings are there, and the recording is also there. I think what if you feel like that you don't you need to understand, just look at the recording. Put the balandapo. හරි දෙක පාරක් හිමීට slow කරලා ඒ කැලේ විතරක් බැලුවා you will be okay. Question number 29. Write down the reaction of the thermal decomposition of ammonium dichromate, stating proper physical states, then calculate the enthalpy of the thermal dissociation of this data. So ammonium dichromate, we discussed this ammonium salts decomposition, right? Ammonium dichromate, I told you, it's an orange color material. When you thermally decompose it, you get nitrogen gas. And then you get a Cr2O3 green color solid, and also some amount of water vapor. So let us say this is given in the gaseous form. Right. So in order to balance this, this should be 4 times 2, 8, 4 times 2, 8. This is the reaction. It says this. Formation enthalpies are given, right? What are the formation enthalpies? Nitrogen, right? And then you have chromium solid, and then you have oxygen. And then other than that, you need hydrogen also. That is how you form this. Nitrogen, 2 nitrogens. 2 times 4, 8. That means 4. Oxygen thina 7. 7 divided by 2. Chromium thina 2. So what would you get? Ammonium dichromate formation is given there. Here the 1810 minus 1810 kilojoules per moles. Nitrogen we don't have to form because it's an element. Cr2O3 we have to form. They have given 1140 kilojoules per moles. Water also they have given 240. Water is given 240 minus 240 times 4 kilojoules per moles. This is delta HR. 1810 plus delta HR is equal to minus 1140 minus 240 times 4 kilojoules per moles. I think the easiest method is cycle method. With cycle method, you can do like, many questions. Very difficult ones also, you can handle them. Minus 1140 minus 240 times 4 plus 1810. 290 minus 290 kilojoules per question number up to that point. So question number 30 වෙනකන් ඔන්න මම ගොඩාක් ඒවා discuss කරා except 1 or 2 questions. All the others were discussed. ඉතින් again the next week I want you to try to at least bring this up to question number 40 වගේ වෙනකන් කරමුද? 31 to 40 at least. I think that's a fair enough challenge to do. Can we do that? Up to question number 40 next week? Right? Okay. So next week, question number 40. Right. Okay. So try that. Question number up to 40. Yeah, another 11 minutes I will spend on a chemical calculation. Right? We'll look at it. Chemical calculations are chemical calculations only. So that's why, we are still working on these calculations every day. Api balamu question number 12 in chemical calculations. Cal. Question number 12. Right? In the tutorial. Right. The active ingredient of an antacid tablets like Digene, this milk of magnesia, those kinds of materials, where it will reduce the acidity of this, contains only calcium carbonate and magnesium carbonate. You have calcium carbonate is there, and you have magnesium carbonate. The complete reaction of the sample of the active ingredient requires, complete reaction requires 0.0875 molar. What is this? 41.33 milliliters of HCl. Right. The chloride salts from the reaction was obtained by evaporation, and the filtrate from the titration, they weighed 0.19. Right? So you get calcium chloride and magnesium chloride. The total weight is how much? 0.19. 0.19 gram. What percentage mass of calcium carbonate as the active ingredient? So what is the percentage of mass? What is the percentage of mass in the active ingredient is there? So these are the only two that is there, right? So let us do that. I think right? So you know calcium carbonate. When you treat with HCl, it gives you calcium chloride, water, and carbon dioxide. How many? So 2. Magnesium carbonate, when you react with HCl, it gives you magnesium chloride, water, and carbon dioxide. Let us say you have X moles here. Make it X moles. And this is Y moles. If that is so, can you tell me how many moles of HCl do you need to complete the react? If this is X, this should be 2X moles. If this is Y, this should be 2Y moles. What is the total number of moles? Total HCl? Total HCl. How much? From the first one, you get 2X. From the second one, you get 2Y's. 2X plus Y. That is equal to how much? 0.0875 times 41.33 10 to the power minus 3. What are these two are equal? So you can now get X plus Y is equal to how much is that? 0.0875 times 41.33 10 to the power minus 3 divided by 2. So 1.8 10 to the power minus 3. Did you understand that? Is it clear, everybody? Now, before going to the other one, please tell me whether you understood that part. Is it clear? Right? Everybody understood that part. Right. So 1.8 10 to the power minus 3. Right. Now, if you have X moles, you get X moles here. If you have Y moles, you get Y moles here. What is the total mass? What is the total mass? Total mass. Right. So mass of calcium chloride. Mass of calcium chloride is equal to number of moles times the molecular mass. Here the number of moles is X. What is the molecular mass? 35.5 times 2 plus 40. Again 111 X. Mass of magnesium chloride, how much is that? Number of moles times the molecular mass. Y times, what is the molecular mass? Magnesium is 24. 35.5 times 2 gives you 95. 111x plus 95y is equal to how much? the total weight of magnesium chloride, calcium chloride, 0.19. 0.19 grams. Did you understand that? Those two equations. Those two equations. Did you understand those two equations? Right, okay. Everybody okay with that? So now what you do is you solve these and you calculate the value, right? So let us say x is equal. What is x? From the first equation, I know x is equal 1.8 10 to the power minus 3 multiply my minus 3 minus y. Making. You took y onto this side. So substitute 111 1.8 10 to the power minus 3 minus y plus 95y is equal to 0.19. Here then 111 minus 95 yani 16y is equal to 111 times 1.8 10 to the power minus 3 minus 0.19. So 9.8 10 to the power minus 3. You simplify it. So you can now calculate y. 9.8 10 to the power minus 3 divided by 16. And 6.125 10 to the power minus 4. Moles. Now, x plus y is that value. So you can calculate x. What is x? 1.8 10 to the power minus 3 minus 6.125 10 to the power minus 4. 1.1875. 10 to the power minus 3 here. It's a little bit of a crazy decimal calculation, but you can solve it now, but at least you get the idea from that. So you know the total weight. What is the total weight? Total mass. What is the total mass? X is calcium carbonate. So 1.1875 10 to the power minus 3 multiplied by 100. Multiplied by 100 is equal to 0.11875. 0.11875 is the calcium carbonate mass. What is the magnesium carbonate mass? Magnesium carbonate mass is given by Y, I think. Yes, Y. Y is equal to 6.125 10 to the power minus 4 multiplied by what is the molecular mass of magnesium carbonate? Magnesium is 24, carbon is 12, the other one is 48, 84 again. 6.125 10 to the power minus 4 multiplied by 84 is equal to 0.05, 0.05145. In a total weight, what is the total mass? Total mass, you add these two together. 0.11875 plus 0.05145. So 0.163. 3 grams. Right? What is the percentage? Percentage of what do they ask? Percentage of calcium carbonate in the active ingredient. ඊට වඩා නම් එනවා ඇති මම හිතන්නේ මේක නම් උත්තරේ. Don't know. Well, make a point 0.5145 divide by 0.163 multiplied by 100%. 0.05145 divided by 0.163. 100%. Magnesium carbonate, you get it as 31.5. 31.5 kilo magnesium carbonate. And the calcium carbonate percentage is 100 minus 31.5 is equal to 68.5. But I think they are roughly okay. But that is how you do it. Right? Okay, I'll send this document, all right? Question number 13, we'll do it next time, right? Now it's like 9:30, so we will work it out. So next week, now our priority is energetics, right? Priority is energetics. So try to do up to question number 40 at least, from 31 to at least up to 40, yeah? Right. If possible, I noticed that someone has said this person has done up to question number 17, that tutorial. And that's a right lot of work, nice work, right? Okay, so we will do that, right? Okay, so we'll meet on Saturday and we'll continue with organic. There's some questions that I have asked you to do on quantitative analysis. Right? Okay, and put a good night, right? We'll stop at this point. Thank you. Okay, bye.